Welcome. In this video, Redgate's Grant Fritchey discusses using local and hosted build agents in Azure DevOps.
The agenda here is simple. We're going to talk about CI, continuous integration on Azure DevOps. We're going to talk about hosted agents and local agents. And so this is purely a technical thing, and what we want to talk about is Azure DevOps. I'm going to let you read that yourself. You don't need to have me read it for you. And the idea here is Azure DevOps gives you a centralized cloud-based method for doing automation, which is cool, but you've got the ability to do it in such a way that you can do it all entirely in the cloud or in some kind of a hybrid environment, and it gives you a lot more power because of that hybrid environment. But when you're looking at distributed global organizations where you've got developers in Romania maybe and India, as well as here in the States, you're going to need to have a way to coordinate everything that they do, and going online is a great way to get that done. Now, this complete platform of Azure DevOps, this is the Microsoft documentation. That's why it looks like an eye chart. But you've got that there, and you can see what it is, and you can see the link to it if you want to follow that link and get an idea of the whole thing. But it is a complete mechanism for doing your development. It's not simply talking about continuous integration. But today, I do want to focus on the CI aspects, the continuous integration aspects. And I do want to focus on Azure DevOps Pipelines. Now, CI is a great mechanism. It's what we do to ensure that the development that we're doing has a mechanism for being tested as we develop. So we're not dependent upon secondary testing bodies, secondary testing organizations within our teams, but rather we are automating the testing process as a fundamental step of the development process. And that's what CI gives us. Now, using Azure Pipelines to build our CI process means that we can build and compile our software in one spot. We can test those builds in one spot. We can get the results back to the people who are doing the coding, because that's who needs to have it now, and it all comes from a single source. And we get to produce an artifact that we can then carry from one environment to the next. So after we finish our CI process, we can still get on and start doing it with QA and pre-prod and on into our production environment if we want to set it up that way. But that's why the Azure Pipelines become so powerful. While we're focused on the CI here, you do want to think about the idea that the more you automate, and as you automate, you can move from a position where you are automating only this CI process, but then you can move into automating more and more. And so it's a great proposition. Now, the thing to think about for the Azure Pipelines is that they are an orchestrator for the automation. It is not the automation itself. You have to do the work and set up the mechanisms that it's going to automate for you. But once you set that up, once you do that work, then it automates all those processes, and it decides what's going to happen, and it decides when it's going to happen, because you can set up triggers. You can set up scheduling if you want, say, a CI process to run once a day, morning, night, whichever you think is best for your environment. Or you can set up triggers such that, say, every time someone branches the code, or every time someone does a pull, or every time a pull gets approved. You can set up the triggers any way you need to, but you can ensure that the CI process acts to get things done. Now, the agents, which is what we're talking about today, are the thing that does the work that you've defined. They're what takes the defined build or the defined deployment and does that processing. And they can do it either up in the cloud along with the Azure management, or they can do it down on your own machines or even on VMs out on the cloud or anything else. But those agents are managed by the pipeline. The pipeline delegates the work to the agent. The agent does the work wherever it does the work. And then the results are sent back up to the pipeline into the Azure DevOps pipeline. And that's pretty much in a nutshell what we're talking about today, is just that process. So the CI process is actually not that hard. I always hate saying that automating these things is easy, because it's not easy because it's a lot of work. There's a lot of moving parts that you need to know, and there's a lot of things that you have to kind of get set up. But the cool thing about it is that what we have is very well documented, and it is easy to implement, even if it's going to be a lot of work. You're still going to have to do labor to get it set up, right? There's not like, when I say easy, I don't mean free and cheap. I just mean not difficult. It's going to be work to get it going, but you can do it. Now, you are going to have to if you're going to use this from Azure, you need to set up a repository. That's the first thing. Now, that repository has to be accessible from Azure, but it does not have to be in Azure. So you can use GitHub. You don't have to use the local version of Git that Microsoft supplies. You could use GitHub if you wanted to. You could use ADO. You could use one of the other source controls. But you are going to have to get a repository set up that Azure can see. And you're going to have to make that possible for Azure to get access to it as part of the CI process. Next, you will then build a pipeline. And the pipeline is just a set of instructions. But the instructions are going to only run what we tell it to. So the idea here is this is a sample pipeline, very simplistic. It's using some of the Redgate tooling, and it builds a database, right? This is what it does. By build, what we mean is put together the database itself, have that full database done. We then run T-SQL-T unit tests. So we have an automated testing engine that's going to run against it. And T-SQL-T, for those who don't know, is an open source testing mechanism for testing SQL Server. If you're using SQL Server, there's other testing tools for other database management tools. But what we're talking about here is T-SQL-T. And then we're using our integration tool, Redgate DLM Automation, to then take the script necessary to create the database that we just tested and build an artifact. Now, what do we mean when we say artifact? Well, in the case of SQL Server, T-SQL. But we do use the pipeline mechanisms, and the pipeline mechanisms are dependent upon establishing oh my gosh, I've forgotten the word. The artifact is well, anyway, it's a zip file with T-SQL inside, and that's what we deploy. And it's just the mechanism that the Azure pipeline uses. Now, when we create our agents, we automatically have at least one pool, right? There's no choice. You've got one pool, but you can set up multiple pools. And the pools are just a collection of agents. It's a way to manage them, set up security around them. And by the way, you can set up security on individual agents as well as on pools. So the security aspect is very flexible. There's a lot you can do with that. But we can take a pool and let it assign one agent to a process or assign lots of agents to a process. So for example, if you wanted to deploy to 10 databases at the same time, you could set up 10 agents and have them do the 10 databases. And that could be on 10 servers or 10 machines or whatever. You could set it up however you need to. Each agent is its own separate software process. So each one is going to use up a little bit of memory, a little bit of CPU, and then it's going to run the commands that you give it. Now, the hosted agents are in a single pool, and then local agents are in one or more pools that you define. So again, the level of control you have here is extremely high, and the level of flexibility is also equally high. So how do we decide what pool we want? Well, once we've created pools, there's pool management, and the CI process inside of Azure DevOps and inside the pipeline lets you pick which one you're going with. So in the example on your screen, we've got one hosted with all the Azure pipelines and 4 different pools that are private. So we've got a default, which if you don't pick a pool, that's the one that's going to get used. Spectre, the Spectre pool, and then the VIO pool. And so each of these is a different pool that's going to have a different set of agents going to different servers, and you can assign them different work depending on what you're doing within the system, which makes it very flexible. Again, it's the flexibility of it, I think, is probably the biggest power we have. That combined with the fact that it's all up in the cloud, so therefore it's a centrally managed thing and centrally accessed by your entire team, but it can then use these different agent pools to deploy to the places it needs to around the world. So there's a lot of power here and a lot of flexibility. So when we do a hosted agent, you do have to realize that it's going to create a virtual machine. That's part of the Azure cloud. It's going to be up in the provision environment, up in the cloud. And this machine is going to be what runs the tasks in your pipeline. Azure is going to handle all the security. Azure is going to handle all the hardware management. You don't need to worry about any of that stuff. You're just telling it, hey, run an agent, and the agent is going to do X, Y, or Z. You can define what kind of agent you get, meaning what kind of operating system you get. Is it going to run Windows? Is it going to have SQL Server on it? Is it going to run Linux? Is it going to be a Mac OS? You can make these choices as you define these hosted agents. And you can have more than one. So you're not stuck with, well, we had to define Windows agents, so we can never deploy to Linux. No problem. You can create a Linux agent as part of that pool. And then if you decide to assign different aspects of your CI process to different OSs, you can do that just fine right through the same interface that everyone else is using. So you've got the same level of automation. So if we choose a hosted agent, you're going to pick the Azure Pipelines, and then you can see right there, as I defined, you've got the Windows agents, the Ubuntu, and then the Mac OS. So you can get whatever you need to. Now, let's see, that looks the same. That is the same. Okay, what's going on? That was weird. All right, so for you, this is the Microsoft page where you're defining a hosted agent. But if you're building with a hosted agent, you've got to remember that the execution is going to use the type of agent that you define. So if you're expecting to deploy to Windows, you best have a Windows agent and pick the Windows agent. If it doesn't provide, doesn't provision what you need, then you're going to have to change that. If you're not set up appropriately, you're going to have to change it because it will cause you issues otherwise. But otherwise, other than that, it's just running your own CI process and off it goes. There's nothing to it. Now, local agents are just as simple, but actually add a lot more power. However, they also add a lot more work. Now, local agents are pretty easy to define. Again, it's a piece of software running on a machine that you have. I do a lot of demos myself with this, and I have a VM running locally, as well as my machine. And so my hardware has got an agent, and my VM has an agent, and then I can call both agents from Azure and have different things occur on my machine through two different agents. And so it makes it for more interesting demos. So you are going to configure this using a local command, and it all has to be downloaded and run locally. You have to run this stuff locally. The agent has to have connectivity back up to Azure because it is running as an agent of the Azure service. And so if it can't see Azure or Azure can't see it to communicate either way, you're going to hit problems. So you've got to make sure you can do that. Security is done through a personal access token, which you will have to generate your own PAT. And once you've got that, then you can define the security so that this thing will only connect up to your Azure stuff, and your Azure stuff will only be communicating to this, and it makes that connection very secure. You can run it as an interactive service, which I don't generally do. I like to set it up as a full agent, so it runs completely in the background and runs on its own, and I don't have to actually fire it up to make it do things or let it do things. I let it run completely as a service. There's actually one running on my machine right now. I don't turn it off, so that it's available for whatever I need it to do. And you can see here, this is the interactive mechanism. What they're doing is making the connection and firing off the agent manually to have it run. And that does require then that you're going to see the things occurring. There are positive and negatives to seeing what's happening. I like to not see it. I want it to just run and happen, and then then everything occurs. Now, if you are doing hosted agents, you don't have to worry about the advantages are pretty good. You don't have to worry about provisioning or managing your hardware. However, you're always going to have a clean machine. You don't have to worry about networking. But as you start to increase the parallelism of having more than one agent, you have to pay for it. So there's an added cost. It is limited to the software versions that Microsoft supports. So if you're trying to run to an older version of Windows or to an unsupported version of Linux, you're going to have to go local. You cannot run it except the way that they want you to run it. If you want to add any other software besides the services that they provide, that's on you to create through your pipeline. It's really nice for simple projects, but it's not great for anything that's using SQL Server Enterprise features or that needs that third-party software. If, for example, if you're using DBA tools as part of your automation, you would have to make sure that you do an install of that each time that you set up your agents, because you've got a clean VM every time, which is great, but also problematic. The local agents are great because you have complete control over the software and hardware. So you can put exactly what you want, exactly the way you want it, prep it ahead of time, have it ready. You do then need to have that physical agent, that physical software, although, again, I set it up on a VM, so you can run it inside VMs. It works. But it has to look like it's going to a machine, to SQL, to Azure. You are going to have to configure the software and the client, but you only really have to configure them once. Once you've got it set, the communication occurs, and everything's fine. And you can disconnect it when it's not needed and connect it up when it is needed. You will have to manage the machine over time. There's nothing, magical here. If you're going to have that agent available, you've got to have a machine available, and that's just the way it goes, right, if you're making that choice. But other than the initial investment cost that you have to get a machine or to get a virtual machine set up, there's no added cost. You want to make 1 million of these and you've already got 1 million machines, go ahead. You can set it up. It also is great for cross-database dependencies. If you've got lots of a very complex environment, you can have your complex environment be the host for the agent, which gives you a lot of flexibility there. Just remember that Azure DevOps is the coordinator, right? It's the thing that's going to make it all happen, and it's going to run it. You get to pick and choose how you're going to do your agents. So if you're doing hosted, you can do it. If you're doing local, you can do it. And depending on how you set it up, you could do a little bit of both. You could do some hosted and some local. It's a bit of work, but you can make that happen. Just remember, the agents are going to be executing the CI tasks. You may have to configure each CI process you build differently because of the different agents. There may be different installs or different steps required. Certainly, if you're looking at something that's in Linux versus something that's in Windows, you've got to think about paths if you're moving files around, just as an example. Finally, you can make a very specific choice to ensure that the database and servers that you want are set up the way you want them to. I would experiment with them and see which one works best for you in your environment. Everyone's environment's got its own little twitches. Some of them are definitely going to work better with a full-blown local, so that you've got all the control. And some are going to just work just fine in Azure, where you surrender some control, but you get ease of automation and ease of use. And that's pretty much all I have to say about Azure DevOps pipelines and agents, hosted or local. Are there any questions right now? We've got a couple of minutes that we can discuss this. If there's any questions on how to get started with it, how to set it up, what works best. This was meant to be very much a high-level overview. So hopefully we kind of hit the high points, gave you the strengths and weaknesses. And I'm just watching the Q&A window to see if anything comes in. One of the hardest things I found with it is when I first set them up, I was not good about documenting what I intended each agent to be. And when I first set them up, I really let the defaults occur. And so the agent names were meaningless to me the first time I set them up. And so when I went in a week later, I couldn't remember what I did or why. And so one of the things I would recommend if you just get started on it is to ensure that you do some documentation, that you don't let the defaults pick the names, that you pick a name. Let's see. Can I have my agents deploy to the same machines that the SQL Server is hosted on? Yeah, absolutely. That's how I do mine. I do. I actually do for demos. I will work on my VM. I will do coding on my VM through Visual Studio or Visual Studio Code. I will do a pull request to get the code up into the cloud, and from there, I will ensure that I will then merge the branch. And once the branch is merged, that is a trigger, and it fires off a build. Well, I let the build occur again back down on my local machine. So what happens is that it runs back down, and I've got SQL Server instance running on my VM, and it does the build right there. In fact, it does. If that build is successful, it lets the pipeline know that that first build was successful. If the first build is successful, it does a second build again back down on my machine to simulate a CI process and a QA process. So I do a CI process with testing, and if the CI process with testing passes, I then do a deployment to my QA instance. And granted, in this case for my demos, both instances are the same, but it does exactly what you would think for what you were asking. Let's see. When installing SCA on a build server for use with Azure DevOps, is there any special configuration needed for SCA, or is it just plug and play? It is largely just plug and play. You do have to define it from the pipeline to let it know what you're doing, but they're all built into the Azure DevOps pipelines, so you can just get it and download it. Also, SCA fully supports PowerShell, so you don't have to use that pipeline plugin tool, which works, and you can use. You can call it directly from PowerShell. Or, are you ready? You can do it all directly through YAML. You just have to know what the little ID is for SCA to get it going, but then you do use the YAML code. We're not supposed to call it code, but use the YAML markup language to define what it is that you want. So great question. Can I have mixed agents for the same projects? I mean, a local and hosted agent for the same project? Yes. Yes, you can. You will have to do some definitions to make that work, but you can do that. Depending on the steps that you're doing, that may get more problematic because certain steps are doing a thing, and so a thing can't run in two places. So you're going to have to think through what it is that you're doing and how you want it to work. But you can do that. Yes. Let's see. We're doing pretty good. It's all down to what it is that you expect your CI process to do and how you want your continuous integration process to work. Like the example that we showed was a fairly clean and easy continuous integration process. Build a database, run tests against that database, assuming the tests pass, generate an artifact that is then published back into the pipeline so that you can deploy it to multiple other environments as needed. That's a fairly simplistic, although hyper common approach. That's most people, that's kind of their CI process, right? Here's my database, do a test. Does the test fail? Okay, kick it back to the dev team so they can fix it. Does the test succeed? Awesome. Move it forward, whatever forward represents for you and your process. That's extremely common mechanism. Can Azure DevOps be used for desktop apps? Sure, it can be. Again, now that in that case, what you will be doing is you're going to have local agents so that it can be using the apps that are down below. But I've done, I mentioned the reason I mentioned DBA tools is because I've got that installed locally on my VM, and therefore because I'm controlling my VM, I can use DBA tools as part of my Azure DevOps pipeline, even though DBA tools is not a part of Azure or Azure DevOps. It's okay. My agent is running locally, and locally I have certain things that I have control of. And so if you want to have a desktop application and control that desktop application, certainly you can. Now, there's not a GUI interactive feature that the agent is going to somehow click buttons, right, and type into text fields. So there's got to be a way to programmatically control that desktop app. But once you get past that idea, sure, you can do it. As long as there's a command line interface, that the agent will have access to it. And again, this is where things get fun. You define the security for the agent. So you can set it up so the agent has the capability to access a given desktop application just fine. Or conversely, you can set it up so the agent doesn't have access to certain things. You can wall the agent off. The agent can only see this directory on the server. The agent can only run PowerShell commands, and it can only run them. It can't run them as an administrator, right? You can literally narrow down the scope of the agent so that you're in a safe place, right? You don't have to feel like, well, I've put this agent on my servers, now Microsoft has control of my systems. No. That agent, the Microsoft merely controls the communication between Azure and the agent, and then it sends commands to the agent. You control what the agent can do, and that can either be everything or very little. I would recommend leaning towards very little, right? You wouldn't want to give SA privileges to your network to Microsoft. I'm not picking on Microsoft when I say that. I'm just saying that, everybody makes a mistake once or twice, and the moment they make one and you've given everything SA, that could be a bad day. So I really would avoid that if possible.